You're welcome to Excellent Simplified Tutorials.
Logarithm. The first thing you need to know in logarithm is how to call this number here, this stuff here. Some persons will say log a n. This is supposed to be what? This is supposed to be what? Log n in base a. So if you have something like this one you're having very close to the log here is the base. Why the normal number here is the what? The log, right? So if I have something like this log n in base what? In base a. So if you have something like this, what does this mean? Log 8 in base 2. If you have something like this, log 10 in base 10, right? Good. Now, when they ask you to find the logarithm of a number, very simple. The logarithm of a number, something like this. If you are asked to find log n in base a, they are asking you, a raised to power what will give you n? I take that again. If they ask you to find log n in base a now, in base a, what will you raise to? That base raised to power what will give you the number n? I don't know if you get that. For example, if you have something like this, log 8 in base 2, what they are asking you is 2 raised to power what will give you 8? So the answer here will be what? 3, right? So the whole of this stuff, the answer is 3. I'm going to show you the right way to solve it, but for now, just understand the general stuff there. Log 8 in base 2. The equation is 2 raised to power what will give you what? Will give you 8. If you have something like this, what should be the answer of this? 2, right? Because the equation is 10 raised to power what will give you what? 100. And we know that 10 raised to power 2 will give us 100, right? So the answer to this is 2. So if you ask to find log 100 in base 10, the answer is 2. So anytime you're giving something like this, just ask yourself, just look at the base. As you're giving a question, the first thing is look at the base. Then ask yourself, this base raised to power what will give me this number they are giving me? That's your answer. Do you get that? All right. So that's basically logarithm. Let's take some examples before we take the laws. So examples. I will solve some and you solve some for me. Now look at this. And this one you're not solving anything already. The answer is already here. So let me use it to emphasize on that. Already you know that log 100 in base 10 is equal to 2, right? Because 10 raised to power 2 will give us what? 100. This implies that 10 raised to power 2 is equal to 100. This is what this means. Looking at this, log 8 in base 2, you already know it's 3, right? Why? Because 2. This implies that 2 raised to power 3 will give me what? 8. Now, log 25 in base 5, what's the answer? 2, right? Nothing to solve. It's 2. Why? Because 5 raised to power 2 equal to what? 25. So just ask yourself, this base raised to power what will give me the number I'm giving? Do you understand this? Please, if you don't understand, let me see your hand. Because once we go into the laws, we'll still be applying this. We have about 8 laws here too in logarithm. And after the 8 laws, we'll start solving different examples. Any question? Don't solve number 2. So you can start. So the first one, I believe everyone got this first one. Log, not log 2 in base 16, no. Log what? 16 in base 2. So in this case, remember I said the equation is 2 raised to power what to give us what? 16, right? That is the equation. 2 raised to power what to give us 16. The simplest way to solve this is just equate it to an unknown, x. We don't know the answer yet. And remember we said 2 raised to power what will give us 16, is it not? 2 raised to power what will give us 16. So simply this is 2 raised to power x equal to what? 16. I don't know if you get. The other time I said it verbally. 2 raised to power what will give us 16, and that what is what we were writing here. So 2 raised to power what will give us 16. That's why we say 2 raised to power x equal to 16. Now this is the same thing as 2 raised to power x equal to 16 is the same thing as what? 2 raised to power what? 2 raised to power 4, right? 2 cancels 2. X is equal to what? That's all. Is it not? Okay, B. But do we understand this? B says log 32 in base 4. Now, as usual, 4 raised to power what will give us 32. I said you should equate it to what? To x, right? Equate it to x. Now, it means 4 raised to power x equal to what? 32, right? Good. But now, 4 raised to power what will give you 32? We don't know, right? But 4 is the same thing as what? 2 raised to power what? 2 raised to power. So this whole stuff is the same thing as this, right? Is it not? Equal to 2 raised to power what will give me 32? 5, right? Do you see how we bypass that now? So these 2 can cancel these 2. So I'm left with 2x equal to what? 5, right? To get x, I divide both sides by what? 2. So x is equal to what? 5 over 2. This is it now. Do you understand? Yes, the answer can be in fraction depending on how the option is. If the answer is not in fraction, if it's, you can leave it in decimal depending on the option. You can convert it to mixed fraction. If you are converting this to mixed fraction, 5 divided by 2 give me what? How many remainder? How many? 2 remainder 1, right? All over the denominator. That's it. So anyhow the option is. Do you understand that? Number 3 now. That's C. C is log 4 root 2 in base what? In base 2. Log 4 root 2 in base 2. Now they are asking you the same question. 2 raised to power what will give you 4 root 2. Now there are so many approaches you can use in solving this one. 2 raised to power what will give us 4 root 2. And as I said initially, you equate it to an unknown x. So it means 2 raised to power what? 2 raised to power what? X will give me what? 4 root 2, right? Good. Now, from here, I can use different ways to solve this. But let's start with one. I'll use 2 methods to solve this. 2 raised to power x is equal to 2 times 16. Did I change anything? Did I change anything? Let me see who is thinking fast now. Square root of 16 is what? Square root of 16 is what? It's 4, right? So that they took the square root of 16 and brought it out outside. So this is the same thing as 2x equal to root of what? 30 what? 32. This is just one method though. There is another method I can use. This is 4, right? The 4 is outside the bracket, right? This is not 4 to root of 2. This is 4 times root 2. See what I mean here? This is 2 raised to power x will give us 4 root 2. And this is the same thing as 2 raised to power x equal to, this is 4 times root 2. Hope you know. Is it not? 4 times root 2. And this 4, what is the difference between root 16 and 4? What is the difference between root 16 and 4? They are the same thing, right? Because root 16 is still 4. 4 is still 4. Is it not? Are we together? So I can decide to put this, since I'm having a root here, I can decide to have root all through. So this is the same thing as 2 raised to power x equal to root 2 times root 16. So I'll be having 2 raised to power x equal to root what? 32. Good. Can I clean this side? Can I clean here? Oh, no, let me clean here. So we use here. In mathematics, don't cram. Understand. You'll see another approach you can use there. So what we have from there is 2 raised to power x equal to root 32. And you remember from the laws of indices, you see why I said indices is the basis. If we want to remove this square root here, what do? Raised to power what? Raised to power half. Thank you. 2 raised to power x is equal to 32 raised to power half. Remember, half is take the square root. If it is 1 over 3, cube root. Is it not? Now, this 2 raised to power x equal to 32. Let's bring it to the base of 2. 32 is the same as 2 raised to power what? 5, right? And we already have 1 over 2 here. Up here. So we'll be having x is equal to what? 5 over what? 5 times 1 is 5 over 2, right? 5 over 2. How many of you got it? How many of you got it? There's a second way we can use to do this. The second way is shorter. So check this out. From here, from the equation, log 4 root 2 in base 2 equal to x. And we said 2 raised to power x equal to 4 root 2, right? Is it not? So from here, 2 raised to power x equal to 4 is the same thing as 2 raised to power what? 2, right? Is to root 2 is the same thing as what? 2 raised to power what? Half, right? Is it not? This is times. So do you get this, what I did here? 2 raised to power x is it. 4 is the same thing as, there is a times separating these two. So this 2 raised to power 2 will give me this 4 times. To remove square root is the same thing as raised to power half. So I have 2 raised to power half. So this is 2 raised to power x equal to, from the laws of indices, if the bases are the same, and this multiplication, what do you do to the powers? So you take the common base, then you add the powers. So 2 plus 1 and half, 2 plus 1 over 2 will give me what? 5 over 2, right? Please, hope you know how to add. You don't just say 2 plus 1, 3 over, no. This is 2 over 1 plus 1 over 2. What's the LCM? 2, right? 2 divided by 1 is what? 2. 2 times 2, 4, plus 2 divided by 2, 1 times 1. This is 5 over what? Over 2. So we have 2 raised to power x equal to 2 raised to power what? 5 over what? 2. 2 cancels 2. X is equal to what? 5 over 2. Still the same answer. Any method that is good for you. Solve it together. Log 1 over 2 in base what? 2, right? What will you raise to power? 2 raised to power what will give you 1 over 2? That's the equation. And I always say equate it to what? X, right? Meaning 2 raised to power x equal to what? 1 over 2. And remember that 2 raised to power x is equal to, remember that 1 over 2 is the same thing as 2 raised to power minus 1. Because if you want to remove minus, you say 1 all over. Is it not? 2 cancels 2. X equal to what? That's all. Say what rubbish. That's all. Nothing else. Alright, so E says log 1 over 3 in base what? In base 9. 9 raised to power what will give us 1 over 3. That is the equation. Equate it to an unknown, x. Next is 9 raised to power what? X. Give us what? 1 over 3, right? And you know 9 is the same thing as 3 raised to power what? 2x, right? And 1 over 3 is the same thing as what? 3 raised to power what? Minus 1, right? 3 cancels 3, right? 2x is equal to what? Minus 1. Divide both sides by what? So x is equal to what?
Minus 1 over 2.
Is that not all? That's all. Alright, let's solve this together. The first one here says log x in base 10 equal to 4. Remember what we were doing before? 10 raised to power what will give us x, is it not? And so it means 10 raised to power 4 will give us what? X. Do you get? 10 raised to power, before we were having something like this. Maybe you can have something like this. So we said 10 raised to power x to give us this. The same thing now we apply it here. 10 raised to power 4 will give us x. So we have 10 raised to power 4 equal to x. And you agree with me that 10 raised to power 4 is 10 times 10 times 10 times 10. Which is what?
10,000.
So 10,000 equal to x. That's all. That's all. Then the second one there, B, log x in base 2 equal to minus 6. The same thing here. 2 raised to power what will give you x, and you're already given the what. So here we have 2 raised to power what? Minus 6 equal to what? X, right? And you agree with me that x is equal to 1 all over what? 2 raised to power 6. That is the only way we can remove this minus. 1 all over. We remove the minus. So now this x equal to 1 all over. 2 raised to power 6 is what? 64. And this is your answer. Do we get? C. C says log what? Log 16 in base x equal to what? Equal to 2. So now, the unknown now here is the base. Remember we are saying x raised to power what will give us 16. Is it not? So x raised to power 2 equal to what? Equal to 16. So if x raised to power 2 equal to 16, what do we do? Square root. We take square root. Which square root? You take square root of both sides. Good. Because square root will eliminate square, right? Square root will eliminate square. So you can take square root of both sides. If you take square root of both sides, square root will remove square, right? So we're left with x equal to what? There are other methods you can do this, so you can use for this. D now. Log x in base 81 equal to minus 1 over 2. In this case here, this raised to power this will give us x, right? So we have 81 raised to power minus half equal to x. Is it not? Is it not? This is the same thing as saying 1 all over 81 raised to power what? Half equal to what? X. And you know that when they say raised to power half, it's the same thing as say take the what? Square root. So we have x equal to 1 all over what? The square root of what? 81. X is equal to 1 all over the square root of 81 is what? That's all. That's all. Everything. Any questions so far? Before we go into the laws now. Laws of logarithm. So the first one here is addition law.